Alright, we are now going to begin multiplication of matrix. Very interesting. In this matrix multiplication, there are two important things that we need to understand. There are two questions. First we understand the question and then we will start the process. The first question is, what kind of matrix can be multiplied? Question number one, what kind of matrix can be multiplied? This is question number one. And another question is, how can they be multiplied? We are trying to search, we are trying to find the answer of these two questions. If you can get the answer of these two questions, this exercise is over. Am I clear?
Yes, sir.
What kind of matrices can be multiplied? So first answer of this question. First of all, two square matrices of same order can be multiplied. Two square matrices of same order can be multiplied. It means if I have one matrix of the order 2 by 2, then other matrix also should have to be of the order 2 by 2, and then they can be multiplied. If one matrix is of the order 3 by 3, then other matrix also have to be of the order 3 by 3, they can be multiplied. So this is the one type of question which can be multiplied. If you have two square matrices of the same order, then they can be multiplied. Is it understood?
Yes, sir.
Another, if we have two matrices of different order, then they can also be multiplied, but they need to satisfy a condition. There is a condition. If that condition can be satisfied, then two matrices of different order also can be multiplied. And that condition we have studied in class 10 standard. And the condition is, condition for the two matrices of different order to be multiplied is, the number of column of the first matrix must be same as the number of row of the second matrix. If the number of column of the first matrix is same as the number of row of the second matrix, then the two matrices can be multiplied. Is it okay? Yes. Mathematically we can write it as A M into P into B, P into N, where A and B are two matrices, and the order of A is M into P, where M and P are some real number. Is it okay?
Yes, sir.
So the size of A matrix is M by P, and the size of B is P by N. From here we understand that the two matrices are of the different order. The order of these two matrices are different, but yet they can be multiplied because they satisfy the condition. And the condition is that the number of column of the first matrix is same as the number of row of the second matrix. So they can be multiplied. Am I understood?
Yes, sir.
Now we will go back to the first again. Two square matrices of the same order can be multiplied. Two square matrices of the same order can be multiplied. Now if you have two matrices of the order 2 by 2, they can be multiplied, and the size of the product matrix also will be same. If you have two square matrices of the same order, then the size of the product matrix also will be same. Very easy to say. Very easy to understand. If you have two square matrices of the order 2 by 2, then the size of the product matrix also will be 2 by 2. Have I understood?
Yes, sir.
But in this case, when you have two matrices of different order, what could be the size of the product matrix? That is not that so easy. Are you getting me?
Yes, sir.
So how we will know what will be the size of the product matrix if we have two matrices of different order? I'm going to tell you that. Are you ready for this?
Yes, sir.
Very easy again. For finding the condition, we have used this part and then this part. Right? For finding the condition, we have used these two parts. And now these two parts are unused. These two unused parts will help you to find the size of the product matrix. Will help you to find the size of the product matrix. So the size of the product matrix will become row of this matrix and the column of this matrix. This way we will know the size of the product matrix. Is it okay?
Yes, sir.
So we discuss about what kind of matrices can be multiplied. Is it clear now? Yes, sir. Now next topic we are going to see is how can they be multiplied. how can they be multiplied? For that, we need to know the meaning of this line, this design. Right? This is a horizontal line and this is a vertical line. This horizontal line comes from the first matrix and the vertical comes from the second matrix. We will follow this system of doing multiplication. Now we are into how we are going to multiply the two matrices. Whether they are of the same order, whether they are square matrices of the same order, or they are matrices of different order, the process will not change. Multiplication will take place in the same manner. Is it okay?
Yes, sir.
So I have drawn this design, and then there I told you that this row comes from the first matrix, and this column comes from the second matrix. We will have two matrices to be multiplied, right? So in the process, what we do is we take the row from the first matrix. We take row from the first matrix, and the row of the first matrix is multiplied by column of the second matrix. Is it okay?
Yes, sir.
In this process, what we do is we take one row of the first matrix. At time we can take only one row. So we start with the first row. From the first matrix we take the first row only. And that row will be multiplied by first column of the second matrix. You will get many products. So all the product will be added and you will get one of the elements of the product matrix. So after you multiply the first row with the first column, then you have to now go for the same row and the second column, because there will be many more columns. Clear? So again we will go back to the first row, and this row will be now multiplied by the second column. By multiplying you will get so many products, then you have to get the sum of all the product, and this sum will give you the second element of your product matrix. I am going to demonstrate everything. Okay? First I want you to connect that one so that you understand faster. And after this first row of the first matrix is multiplied by every column of the second matrix, then we have to go for the second row of the first matrix. So every row of the first matrix has to be multiplied by every column of the second matrix. This is the process of doing multiplication. Is it okay?
Yes, sir.
Now what we will do is we will take the first row of this matrix, and this row of the first matrix is going to be multiplied by every column one by one. So when you multiply this with this column, you will get one element.
Yes, sir.
So, then you will multiply this with the second column, you will get second element. You multiply now this with this third one, you will get the third element. Likewise, you will go for the other rows also. Is it okay?
Yes, sir.
Now, when you are multiplying the row by column, please look at the board. How will you multiply? This into this plus, this into this plus, this into this no plus. And then what plus? So by doing this, you will get one element. Now we will go to this first row and then to the second column. So this into this plus, this into this plus, this into this.
0.
That's all. Nothing. No need to say anything. Is it okay? So now I am going to show you. Are you ready?
Yes, sir.
Please be with me on the board. 2 ones are 2 plus 3 zeros are 0 plus 4 threes are 12. So all the products are added, and I told you that the sum of all the product will give you one element. So this will give you one element, the first element of your product matrix. Now we are going for the second element. So the same row and the second column now. So 2 threes are negative 6. 3 twos are plus 6. And then 4 zeros are 0. Now with the third column. 2 fives are 10. 3 fours are 12 plus 4 fives are 20. Done. Now the first row is completed. By doing so, you have completed your first row. Now we will go to the second row. So 3 ones are 3 plus 4 zeros are 0 plus 5 threes are 15. Next now 3 threes are 9, negative 9 plus 4 twos are 8 plus 5 zeros are 0. Now last 3 fives are 15, 4 fours are 16 plus 5 fives are 25. Now last row 4 ones are 4 plus 5 zeros are 0 plus 6 threes are 18. Next 4 threes are 12 plus 5 twos are 10 plus 6 zeros are 0. Last 4 fives are 20. 5 fours are again 20 plus 6 fives are 30. And now final answer. After this, final answer. 2 plus 12, 14. Minus 6 plus 6, 0. 10 plus 20, 30 plus 12, 42. 18. Negative 1. 40, 56. 22. Minus 2. And this is 17. Some of you are very, very advanced. Thank you. Is it clear?
Yes, sir.
Now we will see the application of multiplication. Application of multiplication, right? By using the concept of multiplication, we are going to find the value of unknown quantity. So any kind of question, any question you pick from this exercise repeatedly, I am telling you, all are same. So let us see how do we do this. Okay? We are very fortunate that we have only one row. So this row will be multiplied by every column. What every column? There is only one column. It's very easy, no?
Yes, sir.
So this into this, negative 2x, plus this into this, x, plus this into this, 20, is equal to 15. So this whole thing is multiplied and you got only one element because there was only one row and only one column. So the product of this will come only as one element. Is it okay? So this whole thing will become one element. After this we can simplify more. This is just x plus 20. This is one matrix and this is one matrix. This is also matrix, okay? And the size of this matrix is 1 by 1. Size of this matrix is 1 by 1. One row, one column. What is super matrix? Isn't it? Now there is an equal to sign between these two, so we can use the concept of equality, where we say that if the two matrices are equal, then the corresponding elements have to be same. So we can equate it. So we are going to equate this with this and then simplify, get the answer. So this is coming x plus 20 is equal to chenga, and therefore this x is equal to chenga minus kg is equal to minus chenga. Answer. Is it clear? Yes. Okay. This is c minus a whole square. What we will do is, first of all, we will try to find the value of c minus a. We will not look at the exponential term. We will only find the value of c minus a. And we know that c and a are the two matrices. So we have to find the difference of these two matrices. We will see from the question what is c and what is a. So c is 2, 1, negative 1 and then 2. And then a is 1, 3, 2, 1. Everybody is very, very comfortable with this.
Yes, sir.
All of you should be comfortable with it. This is a subtraction of the two matrices. So we will start simplifying the corresponding matrices. So 2 minus 1, 1. 1 minus 3, negative 2. Minus 1 minus 2, negative 3. And 2 minus 1 is equal to 1. You got the answer of your c minus a? Yes, now finally we are going to find the answer of this given question. So this given question, how can we calculate? This is c minus a whole square. This we can rewrite by splitting the power. We are going to split the power. So this can be written as c minus a into c minus a. We know very well that a square can be written as a into a.
Yes, sir.
So similarly we have written that. Is it okay?
Yes, sir.
And now the meaning of this one is that this matrix is multiplied by itself. So we are going to find out. So c minus a is calculated 1, negative 2, negative 3 and 1. Then same matrix 1, negative 2, negative 3 and 1. Now we are going to use the concept of multiplication. So this will be first row and first column. So 1 1 jar 1 plus negative 2 into negative 3 positive 6. Then go to the second column now. 1 into negative 2, negative 2 plus this into this, negative 2. Now second row and the first column. So this is negative 3 plus this into this, negative 3. Now go to the second row and second column. Negative, negative, positive, 6 plus this into this, 1 into 1, 1. Final answer now, 6 plus 1, 7, negative 2 and negative 2, negative 4, negative 3, negative 3, negative 6, and 6 plus 1, 7. This is your answer. Do you find any difference? Any difficulty?
No, sir.
Thank you. Alright. So, first of all, we are going to calculate the value of left hand side. LHS is equal to AB. And AB is equal to I, 0, 0, negative I. And then B, 0, I, 0. When you multiply, I into 0, 0, 0 into I, 0. You know, whether it's I or it is you, anything multiplied by 0 is 0.
Yes, sir.
Alright? Now, this into this.
0 plus.
Sorry. How come this 0 here? This and then this, right? So I into 0, 0. And then this into this, it should be here, plus 0. Now go to the second column. I into I square. Plus 0 into 0, 0. And then next one. This row and this column. 0 into 0, 0. And then minus I into I. This is plus minus I square. Now, the last one. 0 into I, 0. And then I into, minus I into 0 is also 0. Anybody wants to say anything? Clear?
Yes, sir.
And then we can write this as 0 plus 0 is 0. This is I square. And this is minus I square. And this is 0. After this, you know the value of I square. It is given as equal to minus 1. So this is finally 0, minus 1. This will give you minus 1. And then there is a minus sign. It will become plus 1. And this is equal to 0. You got the answer of your left side. Now similarly we'll calculate the value of right side. So RHS 0 I 0 into I 0 0 negative I. Now we are going to multiply 0 into I 0 plus I into 0 0. Now 0 into 0 0 plus I into minus I square. Last one, I into I square. And then plus 0. Last one, I into 0 0. And then 0 into minus I 0. Is equal to 0 plus 0 0. This is minus I square. This is I square. And this is 0. Finally, we can write the answer. This will remain as equal 0. This is positive 1. This will be negative 1. This is 0. Now you have both the answers in front of you. Are these two same?
No, sir.
So this statement is true, no?
Yes, sir.
Therefore, AB is not equal to BA. Proved. Clear?
Yes, sir.
Thank you.